So today we're going to continue with classes and objects. And there's a lab due tonight. It's lab 6. Let's take a look at that together. In the last lecture, we completed the first exercise, which is to create this number class. And then now there was exercise 2, which I would like to talk about. Exercise 2 is pretty straightforward. You know what? I can't find the stuff that I worked on last time. Does anyone know where I was? Those files. Let's see. Did I log into the
No.
I worked locally here, right? But I cannot find my work, so maybe I put it in old. Let's see. Okay, that's not a big deal. All right, so let's review then. We'll go through the whole thing again. Does anybody have the code done for exercise 1 that I can grab from the repository? Does anybody want to volunteer their code for this exercise that they've completed? Back there? Okay. Let me get your let me get the URL for that. What's your username? Yeah, put it on the repository. Or just
No, it's GTID. Yeah.
No. Let's see, so was it lab 6? Yeah, lab 6. Oh, here we go. So we have 3 files, and we've got the main, and this should be just exactly what I posted on the web page, so you don't need to modify this, although you could remove that last line, which you did. And then there's the header file, which has the UML class diagram, and that looks good. And then there's the declaration of the class. Remember, you need to terminate. You need to add the semicolon at the end of that closing brace. So this is a common omission that is hard to actually fix. So don't forget that. And we have a single piece of data that's stored inside of instances of the class. And it's just an integer called n. You'll see that second section of the UML diagram here is a listing of the data that's internal, the data that comprises the state of class instances. So when we create an instance of the number class, it has some state. Just like when you have memory in the computer, you might have, maybe you're concerned with 8 consecutive bytes of memory, and you're using that to represent a floating point value. Well, the 8 bytes of memory takes on what we refer to as a state, right? So the state is basically, what are the ones and zeros? The 64 bits that comprise 8 bytes. Those bits have a state. They're either a 1 or a 0. They're an on or an off position. So taken together, you've got 2 to the 64 different possible states for that 8-byte block of memory. So just like that, you should be thinking in terms of states. So an instance of the number class can be in different states. So 2 instances of the number class could have different states. They could represent different things. And the state of number objects is completely determined by this one integer n. And normally a class will have many member variables, and taken together comprises the state of that instance. So here we have, that looks good, looks great, what we have here. And then we've got the implementation file, the CPP file. So we need to include the header. That's the declaration of what this class is all about. What are its functions? What are its member variables? And then we go ahead and provide the implementation of the functions. So each function is preceded by the name of the class, with 2 colons rather. Here, this arrow n, that refers to the member variable n. That's part of the class. This n is a different n. This refers to the parameter n that's being passed into the function here. The parameter n has more narrow scope. It's only visible to code that appears inside the function. And the n that's a member variable of the class has broader scope. It's visible to all functions that are in the number class, not just this one function. So the variable that has more narrow scope overshadows the variable that has broader scope. So we need to, when we want to refer to the variable that has broader scope, we need some way of telling the compiler we want the other variable, not the one that's closest to us. The one that's closest to us is the variable being passed in as an argument. The variable that's a little farther away from us is the member variable n that's exposed to all functions. So we use this piece of syntax right here, and I don't want to get into the details of that. Well, I'll just mention it to you, but you don't need to know about it at this point. This is represents the pointer to the instance of the class. And this arrow is how you dereference a pointer. It's how you follow a pointer to the thing that it's pointing to. And actually, this is dereferencing the member variable n. But that's it. I don't want to get into too much more about that. I don't want to get off in that tangent there. So then we have this function IsPrime, and when we call this function, notice the function doesn't take an argument. So we've got an object, say number. We have an instance of the object number. Let's take a look at that. Here we have an instance number. instance of the number class, we call it 9 because we passed in a 9. So that's kind of a logical name to give the instance. So this variable 9 is representing the number 9 for us. That's what we store internally. And so this variable 9, we use what's called the dot notation to invoke a function relative to that object. So the function is called IsPrime. It takes no arguments. And it runs relative to that instance that we're calling 9. So when the function IsPrime runs, this code executes right here. So when that code executes, you need to understand about where the variables, what the variables are doing. What are their scopes? Here we're defining a variable k, which is of type int, and this is locally scoped, and this variable is only visible inside the for loop itself. Let's see if I can highlight that. This is the scope of the variable k. Notice I did not highlight return. I cannot say return k. Return k will not compile because the compiler is going to say k. K is not known. It's not defined at this point because the scope for k is just within the for loop itself. So that concept of scoping is very important. The scope of something, it's how far out does the thing sort of is the object or is the thing present? K is present within the code that I have highlighted right there. It's not present outside of that block. And let's look at another variable, n. Notice there's no declaration of n inside the IsPrime function. That's because n comes in from an outer scope, a scope that's bigger than the function. N is a member variable. Defined, oh, I erased that. Not erased it. N is a member variable that's a part of the class, number class. I'll just pull that up. There's the n in the UML diagram. And here's the n, which is a member variable. This n, the scope of that n, includes all of the functions that are in number. And that's it. If you define a function that's outside of the number class, n is not visible. N is only visible inside functions in the number class itself. But this n is overshadowed by this other n in the constructor, just specifically there. Because there's a naming collision. So the compiler is going to apply a rule. Like I'm going to, if you use the letter n, I'm going to assume that you want me to use the n that has the more restricted scope, which is the function, the number function itself, or the number constructor. But in IsPrime, we don't have a conflict because n is not declared in the IsPrime function. That means the compiler is free to search outside of the function to find n. And it finds it in as a member variable in the number class, again, that you're referring to here. Now this is an algorithm that we've already worked with on 2 occasions. This is our 3rd occasion to work with this same algorithm. We have a value n, and we want to know whether n is prime. So what we do is we try every number k between 2 and n minus 1. Try to divide that into n, and if we get a remainder of 0, then we know n is not prime. Let's return false. But if we go through that loop and exit the for loop, that means we have not returned false because we never found a k that divided evenly into n, so we're going to return true. That's the IsPrime function, and you see the data type is bool here. And here is another function, is divisible by. This does take an argument, an integer called k. We don't have a naming conflict there. We're not passing in an n. See, it would be very confusing to pass in an n here. I mean, we could do it, because then we would just use, n here with a function parameter, and we would have to write this arrow n there to distinguish the two. But it's not common that programmers will use the same name in this situation. Because this k is different than n. It's intended to be different. But in the constructor, the n that's being passed in, well, its purpose is to tell you what your member variable n should become. So then it's common to use the same variable name. It's a type of self-documentation. All right, let's see if this compiles. So when we compile it, we now have two different compilation units. Well, we need to specify those two compilation units together on the command line when we tell the compiler to compile the program. All tests pass. Good. That's what we want. We have what's called a test harness, that the main function in main.cpp. All it does is it tests the validity of the number class. It doesn't use the number class to do anything useful for us. So this is just an exercise. This is an example of how you would do what's called unit testing. So you have a unit, the number class. That's a unit. It's a thing. Let's write code that tries to break it. And you try to break it from all possible directions. If you can't break it, you go, oh, we're done. Let's move on to the next problem. We've got a unit of logic. We have a number class that we can rely on at this point. All right. So I'm going to so you didn't do lab problem 2. So I'm going to do 2. Let's do 2. I'll show you how to do it. So create a folder. And let's go ahead and copy stuff. And this is pretty much how I would like you to do this lab. And let's copy the number class over there. I'm going to use number.start. So that's called a wildcard. It matches against all possible strings. So we have those. And let's see, what was it that we're supposed to do here? It's not this one. It's really crawling today. I don't know what's going on with my system here. Everything is slow. All right, here we go. So in a previous lab, we developed a program that listed all prime numbers between 2 and a number entered by the user. Okay, let's do that. And I'll copy the main program and start from there. We're going to use the number class, so this is good here. We're not going to use assert. I will take that out. We don't need any of this stuff. And we're not going to run any automated testing. So I won't say all tests passed. I'll just say OK. So there we have three classes. I'm saying 3 files. Yeah, I'll use the star here. Everything that ends with a CPP, let's just match against that and send that to the compiler. Let's see if that works. It does. Says OK, good, we're set. And let's go back to main. So we'll prompt the user for a number. We'll read it in. I'll declare the integer first, n. Let's read in the value into n. And then once we have that, we're going to have a loop. Start at k. Well, k is less than n. Increment k. So we're going to let k range between 2 and n minus 1. And there'll be some. I'm going to just do a partial implementation here that's not correct, just to get closer to the solution. So it'll something like this. We'll say like k. So after we enter the number in, we'll tell the user what we're doing. The prime numbers less than 29, whatever gets typed in, say are the following. And then we'll print the prime numbers out here. Let's see. Let's see what that looks like. K was not declared in this scope. There's that word scope. And that is in line 11. Here's line 11. Oh, this should be N. Enter a number. Oh, we need to fix that. That's too hard to read. Let's put a space between the numbers. And we'll keep them on one line so that if we enter a big number in, it won't scroll off the screen. Do I want the number entered by the user as well, or do I want to omit that? What did I say? I didn't say, did I? So you don't have to worry about that. You can interpret it the way you want to. I didn't say inclusive or exclusive. All right. Okay, now it's printing every number. So we're getting closer. What we need to do now is only print the values that k takes on that are prime. And the problem, of course, here is to do it, and we've done this already. We've done this twice already. It's the third time we're doing this. So what we're going to do now is use the IsPrime, it's the number class and the IsPrime function. So let's create an instance of number. I'll call it number. Pass in k. And then if the number is prime, then we'll print k. So now we're making use of our number class. We tested the class already in Lab 1. Now we're using it. We're applying what we tested in Exercise 1. Oops, not in. I don't know why my system is so slow. I think for some reason the video capture is running very slowly right now. All right, so let's compile the new code. And let's run it. And 29 again. There it is. That looks good now. So we got it. Try a different number. 1,000. Not too many. Let's see what 10,000 looks like. $10,000. Is that going to fit on one screen? Will not, right? Scroll off the screen. Okay. We're going to make a bet on that. I'm just going to bet $1 to $1 this time, because I have no idea. All right. It scrolls off the screen, yeah. So you're right. Not going to mess with that. Anyway, that's how to do this problem. And with the time that we have left, what I'd like to do is just talk about another problem, just so that you get to see another example of a class. And I'm going to call this let's model a school bus.
So we have to take out like the divisible by or anything like that.
No, you don't need to modify it.
You don't need to modify that.
No, just because I think in the problem statement I asked you to use the number class that you developed in problem 1. So the idea there is that you developed a class kind of as a general purpose component that you can use in a larger program, and you testing. And then in the second step, you use that thing that you tested. That's the idea. But, I mean, you could have done it, you could have also simplified the number class just to show that the other aspects of the number class are irrelevant for the problem. So you could have actually rewritten it. So that would have been okay if you did that as well. All right, so here we have a main function. And let's create, and this is, maybe in an online application or something, and you're managing the scheduling of school buses, and I don't know, whatever. There could be some business problem that you're working on where you need to represent a school bus or school buses in code. And so normally what you will do as a software developer is define a class called bus or school bus and have inside of that class the information that you need to sort of keep together that describes the information about individual buses that you need to work with. Well, I'll do the header file first. So we'll have a class called school bus, like that. Normally there's a public section and a private section, and we'll put stuff in there in a minute. We won't need the number class, but we'll need the school bus class. And let's think about how we might want to just to play with this. Let's just think of some things that we could do here. Well, we're going to need to create instances. Maybe we'll have bus 1 and bus 2. And bus 1 has, say, it has a capacity of 30 seats, or 30 students, and maybe it has an initial number of students, maybe it's half full, 15. And let's create another school bus instance. We'll call it bus 2. And it has, it's a smaller bus. It only fits 15 students. And it's currently empty. So now the constructor, like the number class, we passed in one piece of information. Now we're passing in information: the capacity of the bus, how many seats it has, and the number of students that are currently in the bus. Let's see how we're going to represent that. And I'm going to start with the UML class diagram. I don't know how big I need it, so I'll just make it big. And I'll make so I need 3 regions there. And the first region is simply the name of the class. And in the second region is going to be the member variables. And we'll make these private. That's the normal convention, is to hide your data and just let outside code access it through accessor methods or other functions. And so we'll have a variable called, say, capacity or seats. And this will be an int. We'll have another variable called occupants. Is that right? Or riders? Question? Start with the what? It doesn't always have to be public-private. There's no rule on that one. Yeah. But the general convention that's considered good practice is to make all member variables private. That means you won't go wrong in this class if you use a minus sign in that middle region in your UML. Occupants. I don't really like occupants. I'm going to say seats, children, students. It's a school bus, right? Students. Seated students. How about like that? That's, you know, it takes a few extra characters to write it out like that. But now the code is unambiguous. And also, it's self-documenting. What if I just said occupants, and then I add a comment? Oh, that's the number of seated students. Well, why add a comment that says number of seated students is what occupants mean? Let's just call the thing seated students, and we don't need a comment. So that's a technique called self-documentation. All right. And then we've already defined a constructor, and it takes seats, which is an int, and it takes seated students, which is an int, so let's go ahead and add these. So I have an int called seats. We have another int called seated students. And the constructor has to be public because The main function needs to make an instance of it. You know what? I'm just going to grab that right. I'll type it up. There it is. Oh, cedars. So here we have the class declaration, but we don't have an implementation. So if we were to try to compile this now, we would get a compilation error. No, actually, it's a linkage error, because it will compile if I did everything correctly, but when the linker goes to try to find the implementation for the constructor, it won't find it. Oh, I'm in the wrong place here. See, we don't have a compilation unit. We don't have schoolbus.cpp. But I want to show you that it will, in fact, compile, but it gives a linkage error. That's LD. And it's complaining about the constructor. It says, I can't find the code that implements the constructor. So we need to provide an implementation for that. We'll do that here. Actually, I want to show you an alternative. We can actually provide the implementation right in the header file. Just like that. So it does nothing. So we pass in seats and seated students, and we do nothing with them. But as you can see, it will compile. So sometimes you'll see implementation code in the header file, especially if it's like a one-liner. All right, but we're not going to do that. So we need to include the header file for school bus. And then we need to define the constructor. And this is the syntax for it right here. I'm going to show you some alternative syntax. This is what we've seen so far. But there is an alternative way of doing this job. It's called using an initialization list, which is actually more efficient. And it looks like this. Oops, no parenthesis here. And with this initialization list, we don't need to do anything in the body of the constructor. The initialization list starts with a semicolon, a colon, and it has the variable name and the its value passed in through this these parentheses. And so this is, this in the initialization list, it doesn't make sense for this to be the parameter name. So we don't need to use this arrow seat because you'll only, in the initialization list, you'll only have in that position, you'll only have member variables, the names of member variables. So that's an alternative form. Now you might see that. So let's look at the what happens if we compile that and run it. Oh. Anybody know the mistake? Redefinition of school bus, of the school bus constructor. It's saying you're redefining the school bus constructor. And then it says here, school bus previously defined here. Where? Oh, in the header file. So I provided an implementation in the CPP file. I also provided an implementation, a different one, in the header file. And it's saying, hey, there's a redefinition there. So let's fix that. That's right. The empty brackets or braces. The empty braces. So we don't want to provide a definition. We only want to provide a declaration here. And there's a distinction between those two terms, those two concepts. You have declarations saying something exists. I'm not going to give you I'm not going to create it here. I'm just saying it exists. Somewhere else it's been created. It's defined elsewhere. I'm saying that this exists. And you can have any number of declarations. You can have different declarations spread out through the code, but you can only have one definition. That's good. All right, so now that we have these two buses, let's think of some operations that we can perform on them. Maybe we'll fill up bus 2. I'm going to add seated students. I'm going to add 15. So now it doesn't have 0 students in it anymore. But let's let's do it like this. After we do that, I'd like to print this. Or maybe we can have an assertion. Maybe that's, I guess I'll do the assertion. That's what I'll do. Let's test our school bus class. After we add 15 seated students, let's assert that there's 15 in there. So we'll call a function which we need to define, get seated students, and compare the return value to the number 15. Make sure that it is 15. And in fact, when we create bus 2 to begin with, let's check to see that, that there are in fact 0 students. And I'll just split that up like that. So we create a bus 2 with capacity of 15 with 0 students. We verify that the number of seated students is 0. Then we operate on the object. We invoke a function which we need to define, add seated students, pass in the 15, and then we check that the number is stored. So we have get seated students that returns an int. And what was the other one? Add seated students, right? Add seated students does an operation, modifies the state of the school bus object, but it does not return any information. So it's a void. If you wanted to, you can add void onto here, or just omit it. And get seated students takes no argument. It takes no information, but it returns a value. It returns int. This is get seated students, and add seated students is a void function. It returns nothing, so we say it's void. Add seated students. Let's see what those look like. So this will be the, say, get seated students. This returns an int. And this is called an accessor, and it's very, very straightforward. We just return the number of seated students right there. And then the next function that we need to implement is add seated students. And we just take our seated students and add the students to add. Everybody know what that is? The plus equals? What's that? Yeah, it's added into here. Don't assign it into there. You know, leave whatever in there kind of there, but just add to it this value. This is an equivalent statement. These two things mean the same thing. So one is, the top one is just shorter. So these are the same. All right, let's take a look. Doesn't say much there, does it? Maybe we need a all test passed statement here. Maybe that'll do it. And let's do this. Let's do this. Let's add one more student. What should get seated students returned? Well, we're exceeding the capacity. So we're not going to put 16 in there. It's against the law. So we have a number of choices. We could say, well, that's an error. Let's throw an exception. Let's just crash. Or let's return false to say that can't do that. Or let's just silently ignore the value and just return. And there could be some other alternatives as well. Let's start by just silently dropping the operation. We're just not going to add one more because we would exceed the capacity. The capacity of bus 2 is 15. So that means we're going to need to add some logic inside add seated students. Well, it's not quite the, I'm going to do a better test here. Let's suppose we put in, this is more complicated. This is a better test. Let's suppose we added 14 students, so one less than the capacity. and then get seated students should return a 14. And instead of adding one student, let's add 2 students. So what do? Do we let one on board and reject the other? Or do we reject them both? I don't know. We got to ask your boss, your client, like you're writing this code for someone else, or maybe you're writing it for yourself, then you can make your own decision. Well, let's suppose you're writing this in the context of a team, as part of a bigger project you're working on with other people. You're a professional programmer. So you're going to look in the specification. What do you want me to do, when this situation happens, when they're exceeding the capacity of the bus? So, for our purposes, if I don't specify that, say, in my problem statement, then you would have to come up with a rule on your own. But most likely, I'm going to specify what should happen here. So let's say that we'll let one student on, and we'll reject the other one. Okay? Let's say that's what we're going to do. So get seated students doesn't come up with 16, in other words. And we need to add the logic to handle this. So if seated students plus the students to add exceeds the seats, then we have a problem. Else, if that's not the case, then we have the normal situation. So if the seated students plus the students to add is not greater than our capacity, then that's this situation here. And we're okay. We're just going to do the normal operation. But if what we're trying to do is it going to work, then we need to follow our policy. What's our policy? To reject both students? To reject all of the students to add, or to add as many as we can? It's the add as many as you can policy, right? So what's our operation? What would you type here? What does seated students become? Anybody? Huh? Seats. I heard it. I heard it somewhere. It's seats. Right. So we just fill it up to full capacity. Let's see if our test code runs. It compiles, it runs. Just to, let's suppose we were expecting the other policy. Let's suppose we were expecting the other policy, that we're going to reject both students. Then that means we're going to have the same number of students after this attempt to exceed the capacity. This is the other policy. What happens now? Well, we have a failed assertion. The code isn't doing it for us, right? So we have to fix that. So here, how would we fix that? Well, you just do nothing, right? So this is the to reject all new students. It's the opposite policy. The opposite, but it's the other policy. And there it is. Okay, that's it. Lab 6 is due tonight at midnight. Is that okay with everybody? I think we can get it done. Everything is recorded. If you don't want to work it out, by yourself, you just look at the video recordings. Yeah. Yeah, the other assignment is due on Saturday. Assignment 2 is due on Saturday. That's right. Yeah.